Let's look at composition of functions again, but this time let's think of this as giving us a function back. So how does that work? Here we're trying to generate a function by inputting one function into another function. Before we were inputting a value given to us by a function into another function, and our result was a value. Now we're trying to put a function into a function to get a function. So what does that do for our notation? So we'll start with an f of x and a g of x, and we're looking for the function that's defined by f composed with g. So notationally, we have f circled g of x, or f composed with g of x. Or alternatively, we can write this as f of g of x. This is the same notation we had earlier, where the only thing we've done is replace the a value that was the inside argument with an x, indicating we have a function. Now, if we think about this inside piece, the g of x, we can label that g of x as a new function, say u. And often when we do that, we drop the of x. So we can say u equals g of x. And when we do that, our notation f of g of x becomes f of u, with the understanding that u is defined to be g of x. And this is a little bit simpler notation. And we're going to use this idea of an inside function being labeled u as we solve our problems. So let's look at an example. Say we're given f of x is the square root of x, and g of x is x squared minus 5, and we're asked to determine f of g of x. So we see here from our notation that the inside function is the g of x. So we're going to use u to be x squared minus 5, and we'll find this f of u. So that tells us that f of g of x equals f of u. Replace the u with x squared minus 5. We have f of x squared minus 5. And now take all of x squared minus 5 and put it into the f function, and we get f of g of x is equal to the square root of x squared minus 5. Let's look at another example. So now we have f of x is 3x, and g of x is x squared plus 1, and we're going to find both f of g of x and g of f of x. So let's start with f of g of x. It looks like what we had before. Notice our inside function is the g. So we're going to let u be x squared plus 1. And then we're going to find f of g of x, which is f of u, which is f of x squared plus 1. So I'm going to take that x squared plus 1, put it into my f function everywhere I see an x, and I see that that just means I have 3 times the quantity x squared plus 1. Distributing my 3, I have 3x squared plus 3. Now, let's look at g of f of x. To find g of f of x, we notice that our inside function is the f of x, so we make that the u. And we're going to find g of f of x is g of u, which is g of 3x. So everywhere I see an x in the g function, I'm going to replace it with a 3x. So I see that that means I have the quantity 3x all squared plus 1. So my composite function here is 9x squared plus 1. G of f of x is 9x squared plus 1. Notice, just like we had in our evaluation slide, that f of g of x is not necessarily equal to g of f of x. We have a 3x squared plus 3 and a 9x squared plus 1, and those are not necessarily equal. Now let's do another example, but this time let's turn the tables. Let's see if we can figure out the f and g that would give us a complicated composite function. So here I want the g to be my inside function and the f to be my outside function. So it's important to note that for labeling purposes. But I'm given the quantity x plus 2 cubed minus 3 times the quantity x plus 2. Now if I observe this function, I notice that this x plus 2 is acted on here in my first term and is acted on in my second term. So we're going to let the inside function be this quantity x plus 2. So u is x plus 2, So for our labeling purposes of composite functions, we say g of x is equal to x plus 2. Now, what are we left with? Let's go back to this u variable. If we think of what's left in terms of u, we're left with f of u equals u cubed minus 3u. So we see that f of x is equal to x cubed minus 3x. So sometimes it's helpful to take this intermediate step of writing things in terms of u, but realize that in the end we want our answer to be a g of x and an f of x. So that's a pair that gives us this particular composite function.